Hello people, I'm Bharat Acharya. Welcome to our fourth video of 8051 microcontroller introduction. Here I'm going to tell you about the additional I/O features which 8051 has. The first one I want to speak about are timers. So 8051 has two 16-bit timers. Okay, see, now you know why I taught you 8-bit and 16-bit. When you say 16-bit timers, you should immediately understand what does that mean. It means this range 0000 to FFFF. How many such timers are there? Two such timers. What does a timer do? A timer counts. That's why timers are also referred to as counters. There's a very thin line of difference between a timer and a counter, which I will tell you whenever I do a course on the timer section of 8051. Anyway, so both timers and counters count. So what do you achieve? If you tell a timer to count, what do you achieve? You get a delay. Q means the processor. So you're doing a traffic light program. Okay, what's a traffic signal program? You show red, yellow, green, put it in a loop, but there have to be delays between all of them, otherwise it will become a disco light. Correct? So you need a delay. So right now I've shown green. After some time, now the green is gone. I want to put in yellow before I put the red, right? So this is the line that turns on the green light. This is the line that turns on the yellow light. Between the two, I need a delay. A 30-second, 50-second, 1-minute delay. Correct? If I don't put a delay, immediately after green, yellow light will come on. Are you understanding what I'm saying? So I need a delay here. One way of doing a delay, there are various methods. One way is you do some dummy instructions. There are dummy instructions like NOP, no operation. They're created for creating delays. They've been put in the instruction set for delays. So you put an NOP instruction and you put it in a loop, you get a delay. But that delay was produced by a program. That's called a software delay. So what's wrong with that? What's wrong is the processor was involved in producing the delay. So during the delay, the processor can do nothing else. This is okay for a traffic light because the processor has to do nothing else. Not in those lights where there's a counter. If there's a counter, the processor has to be free to display the counter. But most traffic lights don't have the counter, so the processor has to do nothing else. So over there, a software delay is fine. But now think of the same situation, but in an oven or in a microwave. In a microwave, you put food inside, you select 30 seconds, you press start. Start means heater on. This is where the heater is on. 30 seconds later, heater off. Between these two, I need a delay of 30 seconds. Here, I cannot use a software delay because if I do that, the processor will be involved in the delay. Then who's going to control the temperature? You not only put 30 seconds, you also decide the temperature, right? The cooking mode, right? Somebody has to keep checking the temperature, switch on the heater when the temperature goes low, switch off the heater when the temperature goes higher than the desired one, so that the temperature is in the range that you want. So for that, you need your processor to be free. What else does the processor have to do? Somebody has to rotate the dish. Otherwise, it will be cooked only from the sides where the heating elements are there. The front side has no heating element, that's a screen. There will be no cooking over there. So the dish will be unevenly cooked. So there has to be a motor on. Somebody has to control the motor to rotate the dish. Somebody has to keep the lights on. Somebody has to still display the seconds on the screen because you can't keep guessing, oh, when will it be ready? When will it be ready? Somebody has to tell you how many seconds have elapsed, how many seconds are remaining. For all of that, you need your processor to be free, which means you can't use a software delay. Here, you want to use a hardware delay. Hardware delay is where these timers come into picture. Processor tells the timer, count 100. Who is counting? Timer. 0, 1, 2, 3, 4, all the way up to 100. Who is free? Processor. Processor is doing all other activities that it's supposed to do. When the timer's counting is over, it will inform the processor by an interrupt, which you'll learn when I teach you what interrupts are in detail, but inform the processor telling delay is over. So here also you got a delay. But here, the delay was not produced by the processor. It was produced by the timer, keeping the processor free to do other activities. Are you clear? That's why you need a timer. So 8051 has a timer. It has two such timers. What is the advantage of having two timers? You can get two delays going on simultaneously. One delay controlling the cooking, the other delay controlling the speed of the motor or displaying the seconds on the screen or anything else. As an example, you set a timer, an alarm in your phone for tomorrow morning 6 o'clock, you want to wake up at 6 a.m. early riser. So you set an alarm for that. So for that, you need a timer to do the delay all the way up to 6 o'clock to raise that alarm, as an example. In the meantime, you're using your phone. You want to do other operations, like you attend a call. Immediately, there's another timer that tells you how many seconds the call have elapsed. You're playing a song. It'll tell you how many seconds of the song has elapsed. So you need multiple timers so that you can do multiple delays simultaneously. 8051 provides you two timers. Such a small chip, still so many features, packed with features. So it has two timers and they are 16-bit timers. 16-bit timers means they don't count only from 00 to FF. They count from 0000 up to FFFF. 65,535 counts can be done. FFFF is 65535. So 0 to FF is 65536 counts can be done. But either way, so it can do thousands of counts, not just hundreds of counts. Are you clear? So that's the meaning of having timers. It also has a serial port. So there are two types of communications in the world. Parallel means multiple bits at a time. Serial means one by one, bit by bit. Parallel communication, of course, is faster because you're sending multiple bits at a time. 8051 does parallel communication on the ports. There are 8-bit ports. You can send 8-bit data at a time. Serial communication is slow because it's bit by bit. To send 8 bits will require 8 cycles. So yeah, it's slow. So should we study it? Yes. 90% communication it will do will be serial communication. What's the advantage of serial communication? Cheap. Cheap. You need one wire to do it. This is serial communication. It's wireless. There is no wire. But there is no wire from here to there. There is a transmitter. If this was parallel communication, I would need 8 transmitters and 8 receivers over there, increasing the cost 8 times. Correct? This is serial transmission. Though it is wireless, it's still serial transmission. So one transmitter over there, here, and one receiver over there will do the job. Many such examples. So you got my point. So you need a facility to do serial communication. 8051 has a serial port. It also has power saving features. It has an interrupt section. And there are many things, but those things you will not understand so early. But these are things which I want to know because these are extremely important. And a student has to know what he or she is expecting when they start learning 8051. So this was a lowdown. These are the things I wanted you to know about 8051. So I wanted you to understand what 8051 is, what are its memories. I hope you got a good introduction. I hope it's created the curiosity which I'm targeting to create. That will and anxiety. Let's learn. Let's understand what is there in all of it in detail. Now, I have my website where I have the whole course of 8051. I've put about 35 videos explaining all the topics of 8051. Each video is about an hour. Next up, my recommendation, immediately go ahead and take the course where you start learning architecture, pins and flags of 8051. Okay? Hope to see you there. Wish you all the best. I enjoyed teaching this. I hope you enjoyed learning also. All the best.